All right, guys. Question number 7. Now, number 7 says, let E be the event that a corn crop has an infestation of earworms, and let B be the event that a corn crop has an infestation of corn borers. Suppose that the probability of E is 0.24, the probability of F is 0.17, and the probability of E and F is 0.09. Find the probability that a corn crop has either an earworm infestation, a cornworm infestation, or both. Now, if we go back to question number 6, the word or means addition, which means we should try to use the addition rule. And in this case, it should be the best approach only because I'm trying to find one or the other or both. So let's rewrite the addition rule. Addition rule 2, of course. The probability of A or B equals to the probability of A plus the probability of B minus the probability of A and B. In this case, because I have E, I'm just going to replace the A with the letter E. So the probability of E or B equals to the probability of E plus the probability of B minus the probability of E and B. The probability of E is 0.24. The probability of B is 0.17. And the probability of A and B is 0.09. When I add and then subtract 0.24 plus 0.17, that's 0.41. Minus 0.09, that is 0.32. And you can do this all at once in your calculator. Just make sure the order in which you do it is satisfactory. All right, let's move on to question number 8. And it says, find the probability. Samantha is taking courses in math and English. The probability of her passing math is estimated to be 0.4, and the probability of her passing English is going to be estimated to be 0.6. She also estimates that the probability of her passing at least, and I'm going to highlight that word actually, at least one of them is 0.8. What is her probability for passing both courses? Let's look at the word at least one. Well, let's look at least first. If I say you have to be at least 21 years old to legally consume alcoholic beverages, that means you have to be 21 or older. Your age has to be 21 or more. So if I say at least one of the courses, find a probability of Samantha passing at least one of those courses, that is equal to Samantha passing one of the courses or passing both courses. So that means if I look at one of the courses, that is passing English, math, and I'm going to keep the word or, both. So that's passing English, passing math, or passing both. This should look familiar to what we did in question number 7. Which means I'm going to use the addition rule once again. And the addition rule, but for this case, I have 2 subjects, math and English. I should have put math first to keep it in order, but the order is not really too important. So the probability of A or B equals to the probability of A plus the probability of B minus the probability of A and B. Let's say A is math and B is English. So the probability of passing math or English will equal to the probability of passing math plus the probability of passing English minus the probability of passing math and English, which is passing both. I'm going to abbreviate English as ENG. Now remember, math or English or both. This right here represents the at least one. So this is 0.8. And 0.8 will equal to the probability of passing math, which is 0.4, plus the probability of passing English, which is 0.6, minus the probability of math and English, which I want to find, which is both right here. And we're going to call that X. And believe it or not, we're going to see this again. When we look at questions, I believe 14 and 15, we're going to see those again. These numbers, this same setup. Let's make some more room down here first. Okay. So that 0.8 equals to 0.4 plus 0.6 is 1. So 1 minus X. Subtract both sides by 0.8. Sorry. Subtract both sides by 1. We want to get X by itself. Excuse me. That's going to be negative 0.2 equals to negative X. Remember, the X is still negative. We want to have X as positive. Let me go up here. To get rid of that negative sign, let's just multiply both sides by negative 1. Negative 1 times negative 0.2 is 0.2. Negative X times negative 1 is positive X. The probability of passing both is 0.2. So I know I took you guys around the world for this question, but I wanted to break it down like, very detailed, step by step, piece by piece, so you can have some sort of understanding how we interpret this question, how we approach it. All right, guys, we're going to do number 9, and then we're going to end this video. So let's zoom in. Now, number 9 says, if the probability of A union B equals to 0.65, the probability of A equals to 0.31, and the probability of A and B, so A intersecting B equals to 0.13, find the probability of event B. So, at least for my class, if you remember back in chapter 2, section 3, or it might have been chapter 2, section 2, one of those two chapters, I had us translate set notation into a verbal statement. And I gave you guys these two things. The word or represents union, and the word and is the intersection. So keep that in mind. We can replace the union with or and the intersection with and. So this can be the probability of A or B. This right here is the probability of A and B. And we can use the addition rule to find the missing piece, which is the probability of B. Because the probability of A or B equals to the probability of A plus the probability of B minus the probability of A and B. So 0.65 equals to the probability of A, which is 0.31. We have to find the probability of B, so we can just call that X, minus the probability of A and B, which is 0.13. On the right side, combine the like terms. So that's going to be 0.65 equals to 0.18 minus X. Subtract both sides by 0.18. Sorry, 0.18 plus X. My apologies. Don't switch your symbols around. Subtract both sides by 0.18. .47 equals to X. And that is the probability of B. All right, guys. Hope number 9 made sense. Hope you enjoyed it. Hope you understood it. Hope you understood 7 and 8. I'll zoom out so you guys can get like a screenshot of it or look at it as a collective. I'll see you guys soon. Take care.